Alright, gang, let's talk about graphing these rational functions. The vertical asymptote and the horizontal asymptote are only two pieces to graphing this whole deal. Here's a step-by-step list of how to graph a rational function. Alright, first of all, simplify both the numerator and the denominator. Factor what you can. And then find the vertical and horizontal asymptotes. After you find them, go ahead and draw those in right on your graph. Then we want to find any intercepts that we can. Find the y-intercepts by plugging 0 in for x. And find any x-intercepts by setting the whole equation equal to 0, and plot any x-intercepts and y-intercepts.
Would these students please report to the office? Nick Kistner, Joey Schiesel, Scott Osborne, and Michael Twitty.
Well, if any of you are at home right now and that's your name that came up on the announcement, you better go to the office. Anyways, so we have the vertical and horizontal asymptotes. We have the intercepts both on the x and y axis. Then we need to calculate some test points on each side of the vertical asymptotes. And then once we have all that, we're going to draw a smooth curve. Kind of an inopportune time for me to try making this video, wouldn't you say? Okay, so we're going to go through this example right here step by step. Okay, the first thing that we're supposed to do is simplify. Alright, so the numerator is still going to be 3x. The denominator is going to be x plus 2, x minus 1. That tells us that our vertical asymptotes are at -2 and 1, and since the denominator power is greater than the numerator, the horizontal asymptote would be at 0. So what I would do is, that's a little bit big there, let's see. I would draw those in. Have a horizontal at 0. I have vertical at -2 and +1. Of course, I already should have numbered these axes. Okay, step 3 would be to figure out the x and y, or the y-intercepts by plugging 0 in for x. If I plug 0 in for x, I'm going to get a 0 over 2, which is just 0, which means I have a point right there. If I find the y-intercepts, beg your pardon, the x-intercepts, I'm going to take this equation and set it equal to 0. Now, the first thing that you would do is multiply both sides by this denominator, which means that 0 times x plus 2 and x minus 1, well, that all just turns into 0. So essentially, we're just looking at 3x equals 0. Oh, goody for us. We already plotted that point. That means it doesn't cross the y-axis or x-axis any other places. Alright, so that means that we need to test on each side of the vertical asymptote. I would test -3, -1, and normally I might do a +1/2, but I don't think I need to because I have that intercept right there. And then +2. Alright, so when I do that, a -3 will give me a -9 over 9 minus 3 minus 2, which is -9/4, or -2 1/4. So I know that I have a point right here. Now I will plug in, and by the way, you understand why I'm choosing these coordinates, because my vertical asymptote right there is at -2, so I want to test right there and right there. I have another vertical asymptote here. I want to test right here and right here. That's going to help me make my graph. Alright, so testing -1 gives me a -3 in the numerator and a 1 minus 1 minus 2, so I get a -3 over -2, which is +1/2 or 1.5. So I have another point right here. Lastly, I'm going to try 2, so I get 6 in the numerator, a 4 plus 2 minus 2, so I get 6/4, which again is 3/2. So again, I have a point right here. And that is enough for me to know what my graph looks like, because it's not going to cross over here. It's not going to cross over here, so it's going to look something like this. And it goes, it's positive, goes through there, looks like that. And here it's positive, it's going to look like this. That's what the graph looks like. Alright, so if you have any questions on that particular problem, then make sure you ask in class. We are going to try one more. I don't, oh yeah, okay. You guys have, well, it's a bit of a mess. I should have scrolled down to show you where I was testing everything. Anyways, let's do it on the next one. Next example. X squared minus 4 in the numerator, x squared plus 4x plus 4 in the denominator. We start by simplifying. Alright, so the numerator becomes x plus 2, x minus 2. The denominator becomes x plus 2, x plus 2. So this is kind of interesting because right away you notice that we have a cancellation. This cancels with that. So essentially we're just left with the equation x minus 2 over x plus 2. One other thing that I want you guys to be aware of. There is a hole at x equals negative 2. Oh, no, never mind. There's still an x minus 2 on the bottom. It's not a solid. Scratch that then. If you were to have one thing cancel out that was different than what was still there, you would have a hole. Let me give you an example as long as I'm talking stupid. X plus 1 over x plus 1, x minus 2. Okay? These x plus 1's cancel, but there would be a hole at x equals negative 1. And still an asymptote at x equals 2. But that's perhaps a topic for another time. Okay, so this is what we end up with. Our vertical asymptote is at x equals negative 2. Our horizontal asymptote, the powers on top are the same as the powers on the bottom. So it's a ratio of the coefficients, which are both 1. 1 over 1 is just 1. Alright, so number 3 is find your y-intercepts by setting x equal to 0. This is really pretty easy. Because what you end up with is this becomes 0, this becomes 0, that becomes 0, so you end up with a negative 4 over 4. Which is negative 1. So it crosses the y-axis at negative 1. As for the x-intercepts, remember that denominator just ends up canceling out. So you set the numerator equal to 0, and you end up with x is equal to negative 2 and positive 2. Okay, so before we test our points, or use test points, like we're supposed to do for part 5, I'm going to end up erasing all this and starting my graph. Okay, so 2, 4, 2, 4, negative 2, negative 4, negative 2, negative 4. I have a horizontal asymptote at 1. I have a vertical asymptote at negative 2. I have one intercept at 2, another one, the y-intercept is at negative 1. So you might already be able to kind of figure out what this graph looks like. Since my asymptote is at negative 2, my test points are going to be a negative 3 and a negative 1. Okay. I wonder if I can save this screen. Well, if I can, I really don't know how to. So we're going to go back up. Our test points, if you remember, are -3 and -1. If I plug in a -3, I'm going to have 9 minus 4 in the numerator, 9 minus 12 plus 4 in the denominator, which is going to give me 5/1. If I plug -1 in, I'm going to have 1 minus 4 in the numerator, 1 minus 4 plus 4 in the denominator, which is going to give me -3/1. Okay, so 5 and 1, or sorry, 5 and -3. So when I graph that, and I got to write everything out again, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4. We had a vertical asymptote at -2. Horizontal at 1. We knew that we had points here, here. We also know that at -3 it was all the way up to 5, which is right here. And at -1 it was at -3, which is right here. So our graph is going to look like this. And that's what we do to graph the rational functions. There's another thing I need to show you in another video whenever the asymptote happens to be a slant asymptote. But this is all you need to know for the first day. So see you in class.